Hello everyone, this is Subashree here. In today's video lecture, we are going to discuss about conductor free space boundary conditions. So far, we have seen the two different types of boundary conditions, conductor to dielectric and dielectric to dielectric boundary conditions. So this is one among the three types of boundary conditions. And here, this is the special case of the boundary conditions. So this type of boundary condition is depicted in this picture. This type of boundary condition is being depicted in this picture, that it has been a medium between one is a conductor, another one is going to be the free space. So as you all know about the free space permittivity, that can be represented as epsilon naught into epsilon r. So now the boundary conditions between the interface, the boundary condition has to be considered between the conductor and also between the considering the interface between a conductor and also a free space. So as you all know about this particular equation is already being written, that for the tangential component and for the normal component, and for the tangential component, this that can be represented as dt equal to epsilon naught into epsilon r into et, which is equal to 0. And for the normal component, we can represent epsilon naught into epsilon r into en, which can be indicated as rho s. So this is what the basic consideration. In this, because the free space is being considered as one of the medium, free space is being considered as one of the medium, so that the value of epsilon r equal to 1. Okay, that is a special dielectric that can be considered, that is actually the special dielectric whose value is epsilon r equal to 1. So by considering that condition, we expect the electric field to be external to the conductor and it is actually normal to the surface. So the tangential component and the normal component can be modified. That can be written as epsilon naught into epsilon t is equal to 0. For the tangential component, the value of epsilon r is being considered as 1. And similarly here, for the normal component, epsilon naught into epsilon r is 1. So epsilon naught into epsilon n equal to rho s. So this particular equation implies that the electric field must approach conducting surface normally. That will be considering as a conducting surface in a normal condition, that is normally. So thank you all. This is all about your conductor to free space boundary conditions.